All right, lesson 8.6 is about perimeters and areas of similar figures. And our objective is to find the perimeters and areas of similar figures. So theorem 8.6 is the perimeters and areas of similar figures theorem. If the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is also A over B. And the ratio of their areas is A squared over B squared. So we can use that to find different things in some different shapes. So let's go ahead and try them out. Example 1, finding ratios of similar figures. The triangles at the right are similar. Find the ratio larger to smaller of their perimeters and their areas. So the shortest side of the left-hand triangle has a length of 4, the shortest side. The shortest side of the right-hand triangle has a length of 5. So, from larger to smaller, the ratio is 5 to 4. By the perimeters and areas of similar figures theorem, the ratio of their perimeters is also 5 to 4. And the ratio of the perimeter of their areas is 5 squared over 4 squared, which would be 25 over 16. Okay, so that one is pretty simple. Then we've got example 2. Find the areas using similar figures. So the ratio of the length of the corresponding sides of two regular octagons is 8 to 3. The area of the larger octagon is 320 feet squared. Find the area of the smaller octagon. All regular octagons are similar. So we know they're similar because the ratio of the lengths of the corresponding sides of the regular octagon is 8 to 3. The ratio of their areas is 8 squared to 3 squared, which is 64 over 9. So we can write a proportion that says 64 over 9 is equal to 320 over whatever the area is of the smaller octagon. So then we are going to use the cross product property to cross multiply. So 64 times A and 320 times 9, which is 2,880. And then we need to divide each side by 64, and we get 45. So the area of the smaller octagon is 45 feet squared. All right, example 3. Using similarity ratios, bonita plants the same crop in two rectangular fields. Each dimension of the larger field is 3.5 times the dimension of the smaller field. Seeding the smaller field costs $8. How much money does seeding the larger field cost? So first we need to use the similarity ratio of the fields, which is 3.5 to 1. So the ratio of the areas has to be 3.5 squared to 1, or 3.5 squared is 12.25, and 1 squared is just 1. So because seeding the smaller field costs $8, seeding the larger field costs 12.25 times as much. So we have to take 12.25 times the $8, and then you multiply those out, and seeding the larger field ends up to be a $98 cost. Okay, a couple check for understanding problems here. The first one is just like example 1. It just wants you to find the similarity ratios. So the ratio of the perimeters, the ratio of the areas. Example 2, the corresponding sides of two similar parallelograms in a ratio is 3 to 4. The area of the larger parallelogram is 96. Find the area of the smaller parallelogram. So that's going to be just like example 2 that we did. And number 3 is going to work out just like the example 3 that we just did. So go ahead and try those. There is one more example we're going to do together before you get started on that. Number 4, finding the similarity and perimeter ratios. So this time we don't know the ratio of similarity. We are given the areas. So the areas of two similar pentagons are 32 inches squared and 72 inches squared. What is their similarity ratio? What is the ratio of their perimeters? So we know that the areas A squared over B squared is the similarity ratio. Because the ratio of the areas works out like that. So similarity of the ratio of the areas is a squared to b squared. Well, in this case, we know that a squared is 32, or the area of one of the smaller pentagons is 32 and the larger is 72. So a squared over b squared equals 32 over 72. Now, we can take 32 over 72 and reduce it, because you can divide both by 2. 32 divided by 2 is 16. 72 divided by 2 is 36. Those are numbers that we actually know the square root of. So that is why we divided by 2. We want to have numbers we can find the square root of. So then, we need to take the square root of 16 and 36. Well, 16 is 4 squared, and 36 is 6 squared. So 4 to 6 is the similarity ratio. Because all we did was take the square root of 4 squared and 6 squared. By the perimeters and areas perimeters and areas of similar figures theorem, since we know that the similarity ratio is 4 to 6, the ratio of the perimeters is also 4 to 6. Okay, and then example 4. The areas of two similar rectangles are 1,875 square feet and 135 square feet, and you need to find the ratio of their perimeters. So that's going to be just like the example 4 that we did. So you have 4 check for understanding problems to go ahead and try. You should have all the information you need to go ahead and get those done. If you have any questions, let me know, and you're all set.